Chapter 10. Percentage and its applications. Percentage. In this chapter, we shall learn to convert percent into a fractional ratio, or which is decimal. This concept is helpful to find profit and loss, simple interest, and other real-life related problems. The word percent is derived from Latin phrase per centum, meaning per hundred. Percent is represented by the symbol and means hundredths too. For example, 70 upon 100 is equal to 70 into 1 upon 100, which is equal to 70 per hundred, which is equal to 70%. 50 upon 100 is equal to 50 into 1 upon 100, which is equal to 50 per hundred, which is equal to 50%. 45 upon 100 is equal to 45 into 1 upon 100, which is equal to 45 per hundred, which is equal to 45%. To convert a fraction and a decimal into a percentage. Rule: in order to convert a fraction and a decimal into a percentage, we multiply them by 100 and put the symbol with their simplified form. Example: convert each of the following into a percentage. 24 upon 100, 7 upon 20. Solution: 24 upon 100 is equal to 24 upon 100 into 100%, which is equal to 24%. 7 upon 20 is equal to 7 upon 20 into 100%, which is equal to 35%. To convert a percentage into a fraction and a decimal. Rule: we divide the given number by 100 and drop the sign of percent. Example: express the following percents as fractions in the simplest form and also in decimals. 55%, 30%. Solution: 55% is equal to 55 upon 100, which is equal to 11 upon 20, which is equal to 0.55. 30% is equal to 30 upon 100, which is equal to 3 upon 10, which is equal to 0.3. To express percentage as a ratio. Rule: to convert the percentage into a fraction in simplest form and then change to a ratio. Example: express each of the following as a ratio. 15%, 7.3%. Solution: 15% is equal to 15 upon 100, which is equal to 3 upon 20, which is equal to 3:20. 7.3% is equal to 7.3 upon 100, which is equal to 73 upon 10 into 100, which is equal to 73 upon 1000, which is equal to 73:1000. Word problems on percentage. The example illustrate the use of the concept of percentage in solving some real-life related problems. Example: Anuj pays 12% of his income towards taxes. If his annual income is 4,20,000, find the amount paid by him as tax. Solution: tax paid is equal to 12% of income, which is equal to 12% of 4,20,000, which is equal to rupees 12 upon 100 into 4,20,000, which is equal to rupees 50,400. Hence, Anuj paid rupees 50,400 as tax. Profit and loss. We have learnt about percentage and simple day-to-day problems on finding percentage. The concept of percentage is also applied in buying and selling goods. Every businessman earns something when he sells his goods at higher price than the price at which he bought them. The price of an item at which a shopkeeper purchases is called its cost price, CP, and the price at which an item is sold is known as its selling price, SP. When the selling price is higher than the cost price, SP greater than CP, profit is earned. Hence, gain or profit is equal to selling price minus cost price. Since profit is earned on the cost price, CP, or therefore gain percent is equal to gain upon CP into 100%. When the cost price is higher than the selling price, CP greater than SP, loss is earned. Loss is equal to cost price minus selling price. Loss percent is equal to loss upon CP into 100%. Sometimes a shopkeeper has to bear some additional expenses, such as transportation charges, labor charges, maintenance charges, etc., for the items before they are sold. Such charges are called overhead charges. Thus, effective cost price is equal to cost price plus overhead charges. Example, find the gain and gain percent when cost price is equal to rupees 600, selling price is equal to rupees 750, cost price is equal to rupees 6,000, overhead expenses is equal to rupees 400, and selling price is equal to rupees 8,000. Solution: CP is equal to rupees 600. SP is equal to rupees 750. Since SP greater than CP, so there is a gain. Gain is equal to SP minus CP, which is equal to rupees 750 minus rupees 600, which is equal to rupees 150. Gain percent is equal to gain upon CP into 100%, which is equal to 150 upon 600 into 100%, which is equal to 25%. Hence, gain is equal to rupees 150 and gain percent is equal to 25%. Cost price is equal to rupees 6,000. Overhead expenses is equal to rupees 400. Effective cost price is equal to rupees 6,000 plus 400, which is equal to rupees 6,400. Selling price is equal to rupees 8,000. Gain is equal to SP minus effective CP, which is equal to rupees 8,000 minus 6,400, which is equal to rupees 1,600. Gain percent is equal to gain upon effective CP into 100%, which is equal to 1,600 upon 6,400 into 100%, which is equal to 25%. Hence, gain is equal to 1,600 rupees. Gain percent is equal to 25%. To find SP when CP and profit or loss percent are given, we can find the selling price by unitary method or by applying the formula SP is equal to CP into 100 plus gain percent upon 100, or SP is equal to CP into 100 minus loss percent upon 100. Example, the cost price of an item is rupees 50. It was sold at a profit of 12%. Find the selling price. Solution: cost price is equal to rupees 50 and gain is equal to 12%. Let the cost price be rupees 100. Then SP is equal to rupees 100 plus 12, which is equal to rupees 112. If CP is rupees 100, then SP is equal to rupees 112. If CP is rupees 1, then SP is equal to rupees 112 upon rupees 100. Therefore, if CP is rupees 50, then SP is equal to rupees 112 upon 100 into 50, which is equal to rupees 56. Hence, the selling price of the item is rupees 56. Alternative method: SP is equal to CP into 100 plus gain percent upon 100. SP is equal to rupees 50 into 100 plus 12 upon 100. SP is equal to rupees 50 into 112 upon 100, which is equal to rupees 56. Hence, SP is rupees 56. CP when SP and profit or loss percent are given. Again, we can solve the problems on finding the cost price by unitary method or by applying formula. CP is equal to SP into 100 upon 100 plus gain percent, or CP is equal to SP into 100 upon 100 minus loss percent. Example, by selling a chair for rupees 1,080, a trader gains 20%. Find the cost price of the chair. Solution: SP of the chair is equal to rupees 1,080 and gain is equal to 20%. Let the cost price CP be 100 rupees. Then SP is equal to rupees 100 plus 20, which is equal to rupees 120. If SP is rupees 120, then CP is equal to rupees 100. If SP is rupees 1, then CP is equal to rupees 100 upon 120. Therefore, if SP is rupees 1080 or 1080, then CP is equal to rupees 100 upon 120 into 1080, which is equal to rupees 900. Hence, the cost price of the chair is equal to rupees 900. Alternative method, CP is equal to SP into 100 upon 100 plus gain percent, which is equal to rupees 1080 into 100 upon 100 plus 20, which is equal to rupees 1080 into 100 upon 120, which is equal to rupees 900. Hence, the CP of the chair is rupees 900. Miscellaneous examples. Example: by selling a sewing machine, a trader makes a profit of 15%. Had it been sold for rupees 120 more, the profit would have been 20%. Find its cost price. Solution: let the cost price be rupees 100 if sold at a profit of 15%. This implies SP is equal to rupees 100 plus 15, which is equal to rupees 115. If sold at a profit of 20%, this implies SP is equal to rupees 100 plus 20, which is equal to rupees 120. Increase in actual gain is equal to rupees 120 minus 115, which is equal to rupees 5. With supposed gain of rupees 5, CP is equal to rupees 100. With supposed gain of rupees 1, CP is equal to rupees 100 upon 5, which is equal to rupees 20. With supposed gain of rupees 120, CP is equal to rupees 20 into 120, which is equal to rupees 2,400. Hence, the cost price is rupees 2,400. Simple interest. In our everyday life, money regulates all our activities. When we need money, we have to borrow it from a bank or money lender with a promise to return the same after a specified period. At the end of that period, we not only return that money, but also pay some additional money. This additional money is called the interest, and the money borrowed is called the principal or the sum. The total money returned after the specified time is known as amount. Thus, amount is equal to principal plus interest. If we represent amount by A, principal by P, and interest by I, then A is equal to P plus I. Interest is paid in the form of a percent per year or per annum called rate percent per annum, denoted by R. The time specified to return the money is termed as time or T. Interest may be half-yearly or quarterly if the interest is calculated on the original principal throughout the loan period. Then it is called simple interest. To illustrate the calculation of simple interest, let us find the interest on a sum of rupees 5,000 lent out for 3 years at the rate of 10% per annum. Here, principal P is equal to rupees 5,000, rate R is equal to 10% per annum, and time T is equal to 3 years. This implies interest on rupees 100 for 1 year is equal to rupees 10. Interest on rupees 1 for 1 year is equal to rupees 10 upon 100. Interest on rupees 5,000 for 1 year is equal to rupees 10 upon 100 into 5,000, which is equal to rupees 500. And interest on rupees 5,000 for 3 years is equal to rupees 5,000 into 10 into 3 upon 100, which is equal to rupees 1,500. Thus, we see that SI is equal to principal into rate into time upon 100. That is, SI is equal to P into R into T upon 100. Example: find the interest on rupees 1,500 for 2 years at 15% per annum. Solution: since interest on rupees 100 for 1 year is equal to rupees 15, therefore interest on rupees 1 for 1 year is equal to rupees 15 upon 100. Therefore, interest on rupees 1,500 for 1 year is equal to rupees 15 upon 100 into 1500. Therefore, interest on rupees 1500 for 2 years is equal to rupees 15 upon 100 into 1500 into 2, which is equal to rupees 450. Alternative method. P is equal to rupees 1500. R is equal to 15% per annum. T is equal to 2 years. SI is equal to P into R into T upon 100, which is equal to rupees 1500 into 15 into 2 upon 100, which is equal to rupees 450.